Hello guys, today we are going to see how the industrial analog communication system work. In industry we have a standard of 4 to 20 milliampere analog current. 4 milliampere corresponds to the 0% and 20 milliampere corresponds to the 100%. 1 milliampere we also name it as a live zero system. It is placed 4 milliampere because of if we place it 0 milliampere as 0%, then we would not be able to detect any fault in the loop. So if there is 4 milliampere flowing in the circuit, the loop will be considered as healthy loop. And about these values, that y4 and y20, then this may be answered as when 4 milliampere gets multiplied by with the 250 ohm resistance, we get 1 volt. Similarly, if we multiply 20 milliampere with the 250 ohm resistance, we get 5 volt. So this is how we can answer that why 4 to 20 milliampere is set, but this is the industrial standard. So this is a graph. Suppose we want to measure the temperature where 4 milliampere corresponds to the 50 degree C and 20 milliampere corresponds to the 250 degree C. So this is how the calibration would be carried out. And this is how our control loop works. We have a measuring device, which is a sensor, which gives 4 to 20 milliampere signal, which is our called process variable, which goes to the controller, and then the controller gives command output, which is also a 4 to 20 milliampere signal. This is known as manipulated variable, which goes to the final control device, which is a normally control valve or a motor controlling the process. So this is how our full control loop works, and we give the set point at the controller, and we can maintain our process value to the desired set point value. So this is how the graph would be 4 to 20 milliampere on the y-axis, and signal would be 0 to 100% along the x-axis. So we can write an equation for this whole graph. Y is equal to mx plus b. M would be the slope and b would be the y-intercept. Here the y-intercept is 4 and the slope is 0.16. So we get the equation y is equal to 0.16 x plus 4. Now suppose we are getting 8.55 milliampere signal from the controller, then how much valve would be open? So if we apply these values to the equation, we get 28.4%. So 28.4% valve should be opened. Similarly, we have a flow meter which is calibrated from 0 to 350 GPM, and if we are getting 204 GPM flow, then the current would be 13.33 milliampere according to this formula, and this would be the graph which shows that we get 13.33 milliampere according to this formula. So this is how our industrial analog current loops work. Thank you very much for listening.